Hello and welcome. In this particular question, we're looking at the proportionality theorem. So they actually give you something here where they say complete the statement, a line parallel to one side of a triangle, or you can even include a line drawn parallel to one side of a triangle, a line drawn parallel to one side of a triangle, and then when you complete the statement, what you will get is something called the proportionality theorem, right? And that's what we're really interested in over here, proportionality theorem. Right, that's what we're interested. We're interested in the proportionality theorem. Now, well, if I were to complete the statement, I'm going to say, well, a line drawn parallel to one side of a triangle divides the other two sides proportionally. Divides the other two sides proportionally. Now, in this particular video, we're not going to go into the proof of the proportionality theorem. I'll save proofs for a specific course on its own. Proportionally. There we go. Now, what exactly does this mean? Well, a line drawn parallel to one side of a triangle divides the other two sides of that particular triangle proportionally. So let me give you an example, and let's work into some of that. So let's get a triangle over there, and let's take it's blue, it's a line. Okay. Oops, my bad. Let's get our shape back up there, and let's get our triangle drawn. Now, if you look carefully, you're going to see that there is a triangle. So what I'm going to do with that triangle is I'm going to break it up, or rather I'm going to label the vertices first. I'm going to say that's A. I'm going to call that over there B, and I'm going to call that over there C. And then I'm going to divide it. I'm going to divide it, and I'm going to use a black line. And I'm going to draw a line that looks... let me just check that over there. Okay, it doesn't look... The gradients don't look exactly the same, but I'm going to draw a line over there. And I'm going to claim that that line, I'm drawing a parallel line. Okay? Now, I'm going to label the vertices there as well. I'm going to make that D, and I'm going to make that E. Now, for starters, you're going to tell me, well, we started with a triangle, and the triangle is ABC, and then I drew a line, right? A line segment. I drew a segment from D to E, and that line was parallel to one of the sides of the triangle. Remember, the triangle's got three sides, right? Okay, so firstly, we can see that DE is parallel to what? BC. And BC is a side of the triangle. BC is a side of the triangle, right? So if we go back to the proportionality theorem, it said if a line is drawn parallel to one side of the triangle, right, then it's going to divide the other two sides proportionally. And that means that AB and AC will be divided proportionally. So what does that mean? Let's see. That tells us that the following ratios hold. It's going to say that the ratio of AD, right, AB over AD is equal. Now remember, I've got the entire side there divided by this little side over there. It's the same as the entire side on this side, which is AC, divided by AE over there. Right, and there we go. Okay, that ratio is true. I can also speak of it this way. I could also say, well, I've got AB over AD. I can also go AD over DB. AD over BD or DB. Alright, so I've got that short side divided by that side, and then this ratio over here, I'm going to get that short side, which is AE over EC. Right, and then finally, I could have also said the long side divided by the short side. That's going to be a third set. That's also true. based on the proportionality theorem, and I need to also say, now if I make this statement, this is my statement, I'm claiming that AB over AD is the same as AC over AE, I need to have a reason for that. And the reason I'm going to put here is I'm going to say proportionality theorem, prop theorem, right? THRM. Let's fix that last one over there. Right, THRM. And then I'm going to then say, I'm going to name my parallel lines. Because remember, the theorem says if a line is drawn parallel to a third side of a triangle, then this statement is true by the proportionality theorem. So the reason for me applying the theorem is then DE parallel to BC. And there we go. The same thing here, same reason, same reason, same reason. So okay, let's take the entire long side. I'm going to say it's AB divided by DB. And I got to keep the order the same. The entire long side is going to be AC divided by EC. Now all of these ratios are true, right? So remember, if you're given three of these quantities, you can find the fourth quantity, or if you're given some measurement regarding the ratio in which it holds, then you can also substitute and find some solutions. Okay, so I'm going to look at an example now. Okay, so I'm going to start with an example. Let's label the vertices that we've got over here. I'm going to make this again triangle ABC, right? And I'm going to then construct a parallel line. Let's make that line DE again, from there to there. Okay, let's make it a little bit higher. Okay, and I'm going to claim that that line is parallel because we are constructing it in such a way that that line is parallel to that. That is D and that is E, right? Okay, so let's say DE parallel to BC with D on AB. D lies on AB and E lies on AC over there. And then we can also say, in my exercise, I'm going to say determine the following with reasons: the length of AD if AE is 15 units. So determine AD, right, if AE is equal to 15 units, right? If AE is 15 units. So basically in the first example we're saying, well, let's determine that if this length on this side is 15 from there to there. Let's determine AD if AE is 15, right? EC is 6 units. EC is equal to 6 and DB is equal to 4. So let's put that in. EC is 6 and DB is equal to 4. Well, I've got 3 of that, and I can now use any two ratios that is true. So let's start. I'm going to say AD over DB, right? I'm going to say AD over DB, which is this length on this side, divided by that length, it's a ratio, is equal to that length on that side. Remember that short piece, this short piece, that's AE divided by EC. And I need to give a reason for that. So let's see what reason I can come up with. Well, my reason is going to be proportionality theorem, and then I'm going to say, what about the proportionality theorem? I'm using it because DE is it's not perpendicular, but parallel to BC. Okay, so there we go. Okay, now all I need to do is substitute because I've got these values, right? So what values am I going to put in? I'm going to put in AD over AD. Do you agree? Now let's actually solve that first and say it's AD is what we want. It's equal to AE over EC multiplied by DB. And AE is 15 units. EC is equal to 6 units. And DB is equal to 4 units. So let's say 15 multiplied by 4, that's 60 divided by 6, and the answer should be 10 units. And there we go. And we use the proportionality theorem. Now, remember when I started this, I said the proportionality theorem states that when a line is drawn parallel to one of the sides of a triangle, the other two sides are divided proportionally. Okay.